Hello and welcome to this NPTEL MOOCs course on Phonetics and Phonology, a broad overview. So we are continuing with speech perception, and as we already know and we have seen in the last few classes, perception of speech sounds reflects a category membership rather than continuous acoustic differences. So we learned about acoustic phonetic invariants and how there are invariant cues, and that helps us to understand speech, human speech. And continuous perception is what you see here in an example there with the stars, and then categorical perception. So these are various types of stars, these are all the same, but this is a categorical difference between the moon, which is not the same as all the stars, which are of various sizes, but we are conscious that these two are different categories. So speech perception then starts with something like a confusion. Suppose, research in speech perception has to deal with all these problems in speech, that one may be confused for the other. When we're hearing speech, we are aware of these possibilities. So we can always hear one word to be different from the other, and a lot of times we mishear or we do not perceive what was meant to be perceived in the same way. So speech perception starts with confusibility, and if we take different classes of sounds, for instance, if we take vowels, we take stops, we take fricatives, then there is possibility that within that group there may be some confusions. So it underlines, so when that happens, there is always a possibility of substitution, substituting one sound for another sound. So hence, we have to start with the hypothesis that predicts that consonants substitute one for the other. So essentially, this hypothesis predicts that if there are consonants, then there is always a possibility that they will be substituted, one will be substituted for the other. So let us begin to think about consonants, right? So if we think about consonants within fricatives, so sometimes, so in English, it is often the case that the is often heard as the, or the is often heard as fur. And what we see here in this slide, which talks about identification task versus the discrimination task, which we had seen before, that we asked the listener to hear a sound and decide whether they heard the sound as p or b, or we asked the listener to hear two sounds and tell us whether the two sounds are same or different. This is the identification task versus the discrimination task, which we are familiar with from our lectures on categorical perception. So, however, there could be also some confusibility between different categories, and assuming that there is perceptual confusibility underlies a pattern of substitution of fricatives in English. So this is what we are seeing here with regard to fricatives. These are all the English fricatives. So now what does this chart tell us? This chart tells us of all the times that F was heard as f, was heard as th, was heard as the, was heard as or the, okay? Or all the times v, so this is f, this is v, v was heard as f, v was heard as v, and also as th or the or s, etc. Now, what we see here is that this is a figure from Miller and Nicely, and the confusions, the number of confusions of the fricatives and the, and given a set of when speakers were asked to listen to these words and asked them what they heard. They often heard th as f. So you can see the number of times th was heard as f. What this chart tells us is that these are the instances of f. How many times were they heard as one of these sounds? So this is a sort of a confusibility map that we have in front of us, and this is from a research done by Miller and Nicely in 1955. How do we come to this sort of a speech perception confusibility map? There is a procedure for this. So we have to collect a number of words and then we have to record them, and then we have to ask speakers to identify the words. And then when they mistake one for the other, we note down the mistakes, and that's how we come to this speech perception map. So to map the perceptual space that caused the confusion that we see here, that ver was heard as fur, thur was heard as fur. So this is the confusion that we're talking about. So we need to convert these confusions into distances. Now the mathematician Roger Shepard had devised a way for doing this. So how to do this? We calculate similarities, and from similarities we derive the distances of one to the other. So the number of times fur sounds like thur is a reflection of the similarity of fur and thur in the perceptual space. So that is the reason, as we said before, that there is confusion of any manner in a perception, is because there is a similarity in the two sounds. And also the number of times thur sounds like fur is reflected as fur and thur, and we will take the proportions rather than the raw count. So this is the perceptual map of fricatives, and this is the matrix which shows if we count the number of times, not the raw times, we take the proportions. So the value 0.75 that we see here is the proportion of F or the fur tokens that were recognized as fur. So out of the 264 times fur that the speakers heard, it was out of that 199 times it was heard as fur. So the proportion is 0.75. And 0.37 here is the proportion of thur tokens that were categorized as fur. So out of the 232 times that thur was given to the speakers, some were of actually fur. So that is 0.37. Okay, so this is how we code the proportions. The P here stands for the proportion, and here the underscript stands for the row label, and the other stands for the column label. So this is how we are mapping the perceptual map of fricatives. And now again here, what is I and J? So what you see here as fur, 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 thur, one is letter for the row label and one is a letter for the script. So basically, if we look at this map again, we put the row label fur and the column label ver, and that's how we arrive at these two subscripts. The subscript that you see here, fur, 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 thur, one stands for the row label, one stands for the column label. So they are indexed as I and J. So I stands for the subscript for the row label, and one subscript that, so subscript that doesn't match and the subscript that match. Okay, so Shepard's method for calculating similarity is from a confusion matrix. So this is how the confusion matrix is calculated. So we take the confusions between the two sounds and scale them by the correct responses. So here Sij stands for the similarity between category I and category J, that is fur and thur in table 1. So we take these values of I and J, as we had just talked about, the two subscripts, and we put them here, and then we add them and divide by the total correct responses, and we get the value. So to get the perceptual distance from similarity, we take so this is another calculation that we have, the two equations. One is where we divide by the correct responses, and the other is where we take the negative of the natural log, and then in maths, this is how we find the distance. This is the perceptual distance, and this is the similarity, and this is the perceptual distance. So this is how we get the similarity, how similar that they are, and what is the distance. And to calculate the distance, we take the negative of the natural log, and this is the formula for the distance. So these calculations are based on Shepard's law, and it states that the relationship between perceptual distance and similarity is exponential. So it can be exponential. So as we can see from, this is the similarity matrix. So the similarities among American English fricatives based on the confusion matrix from Miller and Isley. So, the perceptual map of English fricatives and the is a stop, so it is outside of this map, and the location points was determined by the multidimensional scaling of the confusion data. So, by scaling the data, these values that we have, this is what we come up with. And now two things here, we find clusters, and the circle groups are clusters, and there was a hierarchical cluster found and one which is outside of this cluster. So, the and f were closer and the and v were closer than the. So, something you have to notice here is that how the two voice and voiceless groups are patterning separately, are clustering separately. So, the and f are very close together, so is v, and so are these two sounds v and the, whereas the is patterning with v and the, but the clusters formed are the, f and the, v, and the is outside of this cluster. So, this is how we have the hierarchical cluster. Then look at some other perceptual data that we have. We find similar analysis where it finally shows that why something is confused for something most of the time, because they are very similar to each other, the sounds, and we find them when we calculate the distance between the two sounds. So, the perceptual map of a place that we have here also have similar findings with regard to the confusion matrix. So, let us look at the perceptual distinctiveness of stops. So, similar to what you have just seen, we will look at something similar. So, and now repeating what we have been saying, that perceptual distinctiveness is related to confusability. Less distinct sounds are more confusable. One way to measure confusability is via an identification task. Play a number of consonants. So, in this case we are talking about stops, and ask the subjects to label the stimuli. So, what did you hear? Pa, ta. Did you hear up, at? So, participants will have to write down what they heard, and we observe the rates of confusion as to what was heard as what. So, now the question that we will ask here is that, is place confused more often in the post-vocalic context? Now, this is similar to what you have just seen with regard to fricatives. So, suppose here we have the chart here on one side, on what you see vertically here is the intended vowels, and here we have what was perceived. So, were they perceived correctly? So, E was perceived correctly most of the time, and then there was some confusions. However, if you compare E and E, number of times E was confused for A is much more, that is 694. And similarly, when we have vowels like A, so was very often confused for O, like 1013 times. So, this is something that you see here, what was intended, and then now we as we said before, we calculate the proportions as to how many times E was perceived as E and how many times E was perceived as A. Now we have the proportions, and then we calculate from the proportion. After we find that, we use our similarity formula here, where we divide with the number of times that something was supposed to be perceived as E or A, and then as to what was the actual value they ended up perceiving them as, and then we also find out distances similar to what we have just seen. So, distances, confusion matrices are usually not symmetrical. So, we do not find that if E is perceived as E more, and that its E will not be perceived as E, or E is perceived a lot of times as A, it is not the same thing. So, they are not symmetrical. So, similarity is related to distance in the psychological space by an exponential decay function, and this is a bit more complicated than what we had found, that there is this exponential decay function. Now, the whole point of doing this extensive lecture to you on multidimensional scaling is not to make you understand these formulas that given by Shepard, but help you to understand something, that there is perception is related to confusability. these things can be mathematically understood. And then there are various mathematical equations as to how we can derive those similarities and distances between sounds. And although you will, something to remember is that you will not be evaluated for these distances and similarities. This is just a lecture showing that we can do these things with the help of mathematical equations. And then we come to the end of our presentation today on perceptual confusions with some input on the vowel space. So, with regard to vowel space, there are two nearly orthogonal dimensions that correlate well with F1 and F2. So, with vowels, there is additionally the Forman values that we have, and the dimension that best correlates with F3 is not orthogonal, it is close to F2. So, F3, as we know, is not always the most important Forman taken to understand vowels. So, relations between dimensions of perceptual space and Hertz Forman frequencies are again non-linear. So, we cannot equate the Forman frequencies and what we have from the Forman frequency values in Hertz, how in the perceptual space they are mapping those Forman values. It is not linear, it does not fall in place one on one. The point of making this presentation to you is to show that vowels have complexities which also have to be dealt with differently from the consonants. So, coming now with the brief presentation on confusability that is there in perception, let us now have a brief look at the speech perception theories which are there in the literature and how we understand perception with regard to these, taking into account the various things postulated by these speech perception theories. So, theories of speech perception must be able to account for certain facts about the acoustic speech signal, and there is interspeaker and intraspeaker variability among signals that convey information about equivalent phonetic events. So, the acoustic speech signal is continuous even though it is perceived as and represents a series of discrete units. So, that we have seen that in the last few lectures, that even though speech is continuous, there is no break between the different parts of a speech that we produce, but even then we perceive them as discrete units. So, that is how speech is like. We do not perceive them as the sounds that make up the words and sentences. We do not perceive them as continuous, we perceive them as discrete. So, speech signals contain cues that are transmitted very quickly, about 20 to 25 sounds per second, and simultaneously, and they must also be able to account for various perceptual phenomena. So, speech perception theories have to deal with these issues of speech, that it is continuous but it is perceived discretely, that speech is transmitted very quickly, simultaneously, and all these things must be accounted by speech perception theories. And there is categorical perception, there is phonemic restoration, and episodic memory plus various word recognition effects. And also there are various ways in which speech perception can be understood. So, one is auditory. Listeners identify acoustic patterns by assigning them to stored acoustic representations. So, then we have bottom up. So, perception is built up from the main information in the acoustic signal, in the physical signal. So, these are questions that speech perception theories will have to deal with. Speech always built up from the signal, or is it not bottom up, it is top down? Is it that we constantly map with our knowledge? And then active versus passive. So, cognitive intellectual work is involved in perception, or that nothing like that is involved. So, motor properties. So, listeners extract information about articulation from the acoustic signal. That is what motor theory says. So, that is another aspect that speech perception will have to take into account. And also top down, listeners use high level sources of information to supplement the acoustic signal. And again, is it active, that is cognitive work is involved, or is it passive? Perception relies on passive responses. so that it is completely passive. There is no active involvement of our intellectual abilities involved in perception. So whether it's active or passive, whether it's bottom up or top down, whether it's auditory or motor, these are the different things that speech perception theories will have to take into account while dealing with speech perception, or coming up with an idea which sort of closely tells us in a certain way that we can understand speech perception the way it happens. Now if we see all these categories of speech perception theories, we'll see that most of the things that have been dealt with by speech perception theories are around these ideas: active versus passive, bottom up versus top down, interactive versus autonomous, or passive versus active, auditory motor. So these are the things that speech perception theories are dealing with most of the time. So these are the different theories of speech perception that we have. We have motor theory, we have theory of acoustic invariance, we have direct realism, we have trace theories, we have cohort, we have other like native language magnet or fuzzy logical or logogen. So there are many theories. We will see a couple of them. So here we have the cognitive system, and then we have all these different things that we have to account for, and different theories are accounting for the cognitive system in different ways, using auditory analysis or visual analysis or grapheme phoneme rules or acoustic phonemic conversion. What are different things which speech perception theories are concerned about? Let's have an overview of these things before we wrap up speech perception, and what are the different ways in which speech perception is seen through the lens of these different theories. So let us recap the things that a speech perception theory will have to deal with. So there is the segmentation problem. One, there is a segmentation problem which we talked about in all the previous lectures, and there is the linearity issue. Okay. Segmentation problem. A specific sound in a word corresponds to a specific phoneme, and the ability to break the spoken language signal into the parts that make up words. So this is the segmentation issue, that the signal is continuous, but we have the ability to break it up into the constituent parts. The signal, there is no break in the signal, but that the achievement of human perception is that we are able to break it into the component words and component sounds. That is our segmentation problem. And then linearity principle is that a specific sound in a word corresponds to a specific phoneme. So this is happening in a linear fashion. We are not jumbling up the sounds and still producing the words. These things are happening in a linear fashion. We are still able to break down into the discrete parts, and this is how perception is happening. Although while we are speaking, it is a continuous stream of sounds. So these two problems, issues, principles, like the segmentation problem or the linearity principle, suggest that speech perception is based on a linear correspondence between the acoustic signal and the phonemic units. So this is happening continuously and in a linear fashion. One by one, we are breaking up the words and the sounds and making sense of what is being spoken. So although we perceive speech as a series of separate and distinct phonemes and words, the acoustic boundaries between phonemes is blurred. And although we are perceiving the speech as a series of separate distinct phonemes and words, the acoustic boundaries between phonemes is blurred, and this is what we keep on saying, that a speech signal has very minimal information, but then the speech perception ability is that despite the minimum information, despite all the variation that is possible in the acoustic signal, a listener is able to perceive and discretely break up the sounds, component sounds of a word and a sentence, and in a linear fashion map one to the other, even though the acoustic signal is rife with all sorts of variation, is rife with all sorts of information which may not be always invariant. We heard that in the previous lecture, that not always invariant for instance, the form and transitions, as we can see here, they're subject to change, right? So the speech signal is also continuous. So how are listeners able to recognize speech sounds and words despite wide variations in speaker production? So speaker variations and gender differences, age differences, etc. are the things which contribute to the variation in the speech signal. So normalization is the ability to perceive words spoken by different speakers at different rates and in different phonetic contexts as the same. And then some other things that speech perception theories will have to take into account. First thing is what is the basic unit of a speech perception? So is it acoustic phonemic features? Is it allophones, phonemes, syllables, words? What is the basic unit of speech perception? And then listening in noise. So we are listening and we are perceiving speech in a lot of noise. So there may be other people speaking, there may be noise, industrial noise, there may be noise from vehicles, there may be noise from nature, environment, etc. Yet we still perceive. So and then there can be very general noise coming from virtually almost nothing at all, just distance, etc. So there is always the possibility of noise in speech, and yet we are able to perceive. So that noise element will have to be accounted for by speech perception. And then how do children start perceiving when they are trying to respond to what they have listened to? So it is seen that they focus on syllables and form and transitions. And then specialization of speech perception. In speech perception, a specialized function in humans. Humans are able to do what we know now as categorical perception. And we know that not just humans, we have seen that in the previous lecture, even animals are capable of categorical perception. However, the perceptual magnet effect, we'll study what is the perceptual magnet effect, is not very prominent in animals, so poorly discriminated from typical vowel prototypes. So this is a diagram showing the responses to perceptual magnets of prototypes by American infants and Swedish infants, and then we can see that they respond poorly to perceptual magnets. Again, we have acquainted ourselves with active versus passive theories a bit before, and we know that active theories suggest that speech perception and production are closely related, and listener knowledge of how sounds are produced facilitates recognition of sounds. And passive theories emphasizes the sensory aspects of speech perception, and listeners utilize internal filtering mechanisms, and knowledge of vocal tract characteristics play a minor role, for example, when listening in noise conditions. So active versus passive theories, we have acquainted ourselves with that, and then in one suggests that speech perception and production are closely related. In the other, it emphasizes the sensory aspect. So of speech, knowledge plays a lesser role. The role of sensory aspects of speech is highlighted in passive theories. So active theories put a greater emphasis on our intelligence, human intelligence in perception. And so again, bottom up, top down, we have seen this before. And top down processing works with a knowledge of a listener has about language, context, etc. And bottom up processing works in the absence of a knowledge base, providing top down information. So listeners receive auditory information, convert it into a neural signal, and process the phonetic feature for information. And then we have the autonomous versus the interactive theories. So we will not talk about autonomous versus interactive so much as in the difference between feed forward processing, and because we are not talking so much about processing, but it's good to know that such theories are also there. So these are the different speech perception theories as we have just mentioned. We have motor theory, acoustic invariance theory, we have direct realism, trace model, we have Logosian, we have cohort, fuzzy logic model of perception, native language magnet theory. So what is motor theory? Motor theory given the lack of acoustic invariance, we can look for invariance in the articulatory domain. And motor theory postulates that speech is perceived by reference to how it is produced, and that is when perceiving speech, listeners access their own knowledge of how phonemes are articulated. And motor theory shows that articulatory gestures such as rounding or fronting, etc., these are the actual units of perception. That is what motor theory tells us, and they directly provide the listener with phonetic information. So, the biological specialization for phonetic gestures prevents listeners from hearing the signal as ordinary sound, but enables them to use that for systematic special relation between signal and sound to perceive the gestures. So, the articulatory gestures are the real perceptual units. So, and then there is a biological specialization for phonetic gestures which prevents listeners from hearing the signal as ordinary sound. So, we hear speech signal as linguistic, and we always map it to something that is linguistic and has to be perceived in a certain way, because it is the articulatory gestures are encoded in our perceptual abilities in such a way that they are the units of perception. So, there is a special relation between signal and sound to perceive the gestures. And motor theory commands that control articulation were considered to be the invariant phonetic features. And the revised theory says that it is intended gestures that are the invariant object of perception. But regardless, we have to remember that the gestures, the articulatory gestures, are the object of perception. The gestures are the units of perception. So, that is what motor theory tells us. And these are the various stages involved in motor theory. There is an internal representation, and there is a processing which is involved there, and then this is the received message. So, we have various things in the articulation, the articulatory patterns, articulatory hypothesis, and then these are extracted for articulatory movements, and then there is generation of hypothesis of the sounds based on the neuromuscular knowledge. This is the active processing which is model, and then the reconnection, the connection of the perceived units into larger units of syllables and words, etc., happen in the motor theory. This is the postulation of speech. This is the postulation of motor theory with regard to speech perception. So, we perceive, according to motor theory, we perceive speech discretely, categorically, because sounds are produced with discrete articulators and gestures. In this model, speech perception is based on auditory matching mediated through speech production. When a listener hears a speech signal, he or she analyzes it by mentally modeling the sound. If the auditory result of the mental synthesis matches the incoming acoustic signal, the hypothesized perception is interpreted as correct. So, analysis by synthesis is therefore different from motor theory. In this model, the auditory matching is true speech production. So, this is one of the auditory audition theories where the auditory part is important. So, when the listener hears a speech signal, he or she analyzes it by mentally modeling the sound. So, when you hear something, you model it, and if the auditory result of the mental synthesis matches the incoming acoustic signal, the perception is interpreted as correct. So, a lot of emphasis is put on the auditory part of speech perception here. And then we have the direct realist theory. So, direct realism postulates that speech perception is direct, that is, happens through the perception of articulatory gestures, but it is not special. All perception involves direct recovery of the distal source of the event being perceived, and in vision you perceive objects, likewise with smell you perceive food, flowers, etc., and same in the auditory perception of speech. So, in the direct realism theory, speech perception is direct. What does it mean? It happens through perception of articulatory gestures, but the gestures are not special because there is no intervening process there. So, it is a sensory perception. So, like food, flowers, if you get the smell, you perceive that is food, you get the smell, you perceive that's flowers, and the same thing is with auditory perception of speech. So listeners perceive tongues and lips, and the articulatory gestures that are the objects of speech perception are not intended gestures. So unlike motor theory, here in direct realism theory, the articulatory gestures are where the articulatory gestures are objects of perception. Here it is not so. Here it's not about the gestures, it's about tongue, lip, etc., the different parts of our vocal abilities to produce sound. Those are perceived, and that's how we perceive sounds. Rather, they are the actual gestures. So, and that's how direct realism is understood. So, a trace model, it's a connectionist network model of speech perception, lexical perception, and different levels of speech units are represented on different levels of the network. So, it influences across levels and shares excitatory activation, that is activated features lead to the activation of the related phoneme, and activated phonemes activate units on the word level. And influences within a level, those that are inconsistent with each other are inhibitory, that is the activation of one phoneme level unit inhibits the activation of other competing phonemes. And trace model assumes there is a cognitive unit for each feature, for example nasality at the feature level, for each phoneme at the phoneme level, and for each word at the word level. At any given time, all of these units are activated to a greater or lesser extent as opposed to all or none. When units are activated above a certain threshold, they may influence other units at the same time. And these effects may be either excitatory or inhibitory, and the entire network of units is referred to as trace because the pattern of activation that is left by spoken unit is a trace of the analysis of the input at each of the three processing levels. So, there are three processing levels, but the spoken input is the trace. It leaves a trace in the three levels, and that is why it is called the trace model. So, the cognitive unit for is the feature, and at the feature level for each phoneme at the phoneme level, and for each word at the word level. So, this cognitive unit and the entire the network of units that we have in trace model, so it's a trace basically, and that is why the cognitive unit is a trace, and that is why it is called a trace model. So, for example, a listener hears the beginning of a word bald, and the words bald, ball, bad, bill become active in memory. Then soon after, only ball and ball remain in competition, and bad and bill have been eliminated because the vowel sound does not match the input. Soon after, ball is recognized, and therefore trace simulates this process by representing the temporal dimension of speech, allowing words in the lexicon to vary in activation strength, and by having words compete during the processing. So, there is activation happening at each level, and whatever is activated is basically understood as one of the words which might be the resultant output of the system. Because of the activation strength, the possibility of each word resulting as the output or resulting as the word which will be perceived will be different. So, therefore, trace model is a neural net model, and it aims to identify and activate words, and it accounts for categorical perception and Ganong effect and other traditional phonetic findings that were considered important in the 1970s. So, it is a connectionist model of speech perception. Unlike direct realism, so we have already looked at direct realism, so we will look at cohort theory a bit. Now, a cohort theory models spoken word recognition. It is based on the beginning of an input word and all words in memory with the same word initial acoustic information, that is the cohort, are activated. So, there is a cohort which is activated, and as the signal unfolds, members of a cohort which are no longer consistent with the input are eliminated. So, cohort elimination continues until a single word remains, and the point at which a word diverges from all other members of the cohort is called the uniqueness point. And cohort theory was designed specifically to account for auditory word recognition, and the model posits that when a word is heard, all words beginning with the first sound of target words are activated. And this set of words is considered the cohort. Once first cohort has been activated, other information or sounds in the word narrow down, the choices are narrowed down. So listener recognizes word left with a single choice. That's called the recognition point. So this is a cohort theory. So in stage 1, suppose this was the word stack. So all these words will be activated. So similar to stack: static, stack, stab, stagger, stamina, stampede. And then there might be elimination of some words because they are different. So stab and stack are pretty close, and stamina is now excluded because it is very far from stack. And then stampede and all these are better matches to stack, and all these are activated, and finally they are all eliminated to the effect that the one which is perceived is remaining, and that's the elimination point. Similar also to cohort and in similar models where different words are activated is the neighborhood activation model. And the neighborhood activation models spoken word recognition as the identification of a target from among a set of activated candidates. So these are the competitors. And all words phonologically similar to a given word are in the word's neighborhood, and recognition of a word is based on the probability that the stimulus word was presented compared to the probability that other words in the neighborhood were in fact also presented. So probability is also influenced by lexical frequency, and that is the neighborhood activation model. And then there are other exemplar models like non-analytic approaches. In most of these models, speech perception, the objects of perception are highly abstract, and in fact information about specific instances of a particular word are abstracted away from and discarded in the process of speech perception. So information about a particular speaker or speech style or environmental context can play no role in the representation of words in memory. So information about particular speaker or speech style does not play a role according to exemplar models, and it's a very highly abstract sort of a model where information of the specific instances are abstracted away and discarded in the process of speech perception, and only the abstract information remains. So that's why it's called an exemplar model. And exemplar models postulate that information about particular instances, the episodic information is stored, and these are mental representations that do not have to be highly abstract, but they do not necessarily lack redundancy, and the categorization of an input is accomplished by comparison of all remembered instances of each category. And often exemplars are modeled as categorizations of words, but they might also be categorizations of segments or syllables. Stored exemplars are activated according to the degree of similarity, and activation levels determine categorization. So, and then we have acoustic invariance theory, where listeners inspect the incoming signal for the so-called acoustic landmarks, which are particular events in the spectrum carrying information about gestures which produce them. And gestures are limited by the capacities of human articulators, and listeners are sensitive to their auditory correlates. The lack of invariance simply does not exist in the model, and the acoustic properties of the landmarks constitute the basis for establishing the distinctive features. And very importantly, the acoustic properties are the most important here, the acoustic invariance theory, and there is no lack of invariance in this model, and bundles of distinctive features uniquely specify phonetic segments. So the incoming acoustic signal has acoustic landmarks which the listener is listening to, and that's what the acoustic invariance theory tells us. The two principal claims of the acoustic invariance theory is that there are invariant acoustic patterns in the speech signal which correspond to phonetic features, and that humans perceive these properties, these acoustic invariant acoustic patterns are perceived by humans to provide a phonetic framework for natural language and to process the sounds of speech in ongoing perception. Finally, we have the native language magnet theory, and according to Kuhl's native language magnet theory, the phonetic perceptual space is organized in terms of prototypes. Prototypes are defined as mental representations or perceptual maps of the speech, and prototypes function as perceptual magnets and exert an attracting force on neighboring auditory representations. Thus, the perceptual space appears to be warped in the neighborhood of a prototype because a prototype attracts exemplars. Remember the exemplar theory, where we have different exemplars, abstract features that fall within its region of influence. So, the phonetic perceptual space is organized according to prototypes. Prototypes is extremely important in native language magnet theory, and prototypes are defined as mental representations of or perceptual maps of the speech. So, what are prototypes? These are mental representations or perceptual maps. So, and that is how we create prototypes of our native languages. Data shows that infants perceptually map critical aspects of ambient language in the first year of life before they can speak. And statistical properties of speech are picked up through exposure to the ambient language in the child is growing up. And the linguistic experience alters infants' perception of speech, warping perception in the service of language. And infants are neither the tabula rasas of Skinner described nor innate grammarians of Chomsky, but they create these perceptual maps. Infants have inherent perceptual biases that segment phonetic units without providing innate descriptions of them. So, infants use inherent learning strategies that were not expected once and they are thought to be too complex and difficult for infants to use. Adults addressing infants unconsciously modify speech. So, in infant directed speech, in child directed speech, there is a lot of unconscious modification in ways that assist the brain to map the language. So, the way child directed speech is spoken is in such a way that helps the child to map the language. In combination, these factors provide a powerful discovery procedure for language. So, we come to the end of our lecture on speech perception. In these lectures, we tried to only give you a broad overview of speech perception. We were not able to go into the details of, for instance, MDS or perceptual confusability, multidimensional of an analysis to the help of multidimensional scaling, because this course gives you a very broad overview of these aspects and they have to be. So, if you are interested, then you are very welcome to follow whatever was discussed. Very briefly here, you can consult the book by Keith Johnson, which is there in our list of readings, etc. You can follow those and look into how those things can be actually implemented, even though we did not go into a lot of detail of multidimensional scaling. There is always all those things to follow up if you are interested in greater detail. This course, this lecture especially, was giving you a very broad idea about the issues in speech perception and the ways of analyzing problems in speech perception. And also in this lecture, we gave you a very broad overview of different types of theories of speech perception available, like motor theory, like direct realism, trace theory, native magnet theory, or exemplar models, etc., telling you how different speech perception theories try to accommodate all these complexities which are there, that speech is continuous, yet it is perceived in discrete ways, and how they try to understand or analyze or give us an idea of what must be happening in our perceptual spaces, and how we must be achieving the task of perceiving speech all the time, that is speech. So, and therefore this lecture was also a very broad overview of the problems in speech perception and the different theories which are there. And again, this is an overview. This was not a very specialized lecture on either of these two issues, and you're very welcome to follow up if you're interested in this area. And thank you for listening. We will continue with phonology from the next module, and this brings us to the end of articulated phonetic, acoustic phonetics, and perception. And we will again continue with where we left off with phonemes in the first lecture. We will start again with phonemes and the history of phonology, etc., from the next module. Thank you very much for your attention.